Alright, so today we are going to learn about parent functions. Okay, really we're going to learn the equation, the name of it, domain and range, and then I may throw in the calculator notation here. Okay, so this first equation is called a quadratic. The equation is y equals x squared, and then when looking at this graph, if a graph goes to the edge, then we're going to assume it has arrows. Okay, so the domain, if I'm going left, reveals an arrow, goes to negative infinity, and then right, okay, another arrow, positive infinity. So this is what we've been writing. There is a shortcut. This just means all real numbers on the number line, so every number on the x-axis. So we're just going to do an R with two stems, represents the exact same thing as this. So this is the shortcut. This means all real numbers. Okay, the range, the low value, when I look here, it goes as low as 0 on the y-axis, and then we have our two arrows that mean it continues up forever. So it can equal to 0, and it goes to positive infinity. Okay, and that is a quadratic. All right, the next graph we have is an absolute value. In our calculator, it's going to be abbreviated with ABS. This equation is y equals the absolute value of x. So these vertical lines mean it is the absolute value. Okay. In the calculator, if we were going to put this in, we would hit the y equals button, we would hit alpha, and then window, and that would get us to the ABS, the absolute value. Again, arrows on the end of this. Okay, so to find the domain, we're going to go left, reveal an arrow, that's negative infinity on the x-axis, and then as far right is positive infinity. So the domain here is all real numbers. The range, how low does this graph go? This point is 0 on the y-axis, and then it goes up. We reveal our arrows, that tells us it goes to positive infinity. So from 0 to infinity, a bracket around the 0 because it's a solid line or a solid dot. All right, our next graph is this funky looking one. This is called a cubic function. Okay, that equation is y equals x cubed. On the calculator, you would hit y equals, the x button, the caret button, and then 3. For domain and range, again, this goes to the edge of the graph, so it has arrows, or we assume it has arrows, going left to right. If I go left, okay, this continues down and slightly left forever and ever, so that's going to be negative infinity. Same thing this way, positive infinity. So the domain again is all real numbers. With the range, how low does this go? I reveal an arrow, continues down forever, and then it continues up forever. So it goes to negative infinity to positive infinity. So that is also all real numbers. It's a cubic function. Next, we have this funky looking graph. We call this a radical function. It starts here, and then it has an arrow here. So there is a point here, and then it starts that way, okay? Radical is just a fancy way to say a root in math. Okay, what I mean by that is this equation is y equals the square root, so this is the actual root of x. Okay, square root of x. In our calculator, y equals, we would just hit the second button and then the x squared button. Okay, so domain and range here. How far left does this graph go? To this point on the x-axis, it's at 0. It's a solid dot, so we use brackets. How far right does it go? Well, there's an arrow, so that tells us it goes to positive infinity. The range, how low does this graph go? Intersects the y-axis here at 0. Again, a bracket. And then how high does it go? We have an arrow, so it's ever so slightly going to keep increasing to positive infinity. All right, our next graph is called an exponential. So an exponential function. That equation is y equals 2 to the power of x. So now the variable x is in the exponent. So that's why it's called an exponential function. Okay, calculator, y equals 2 root, the caret button, and then x. All right, so this graph we have to pay attention to a little bit. So it goes to the edge there, so it continues up and to the right. And then right here, it flattens out, okay? And there is an arrow here, but what I want to explain is it flattens out right here and it never gets to the x-axis. So think about taking a number. Like if I had a number 10 and I divided it in half, and I just keep dividing in half each time, on that calculator, it's gonna approach 0. That means it's gonna get closer and closer to 0, but it won't ever get to 0. And so if you ever see a line that's really flat like this, that means it's not gonna get to that value. So if we look at domain and range, the domain is not gonna be affected. How far left does this go? Arrow, negative infinity. How far right? Another arrow, positive infinity. So these are going to be all real for the domain. The range, however, this goes down and it levels off right here at 0, okay? And then it goes to positive infinity. But this time at 0, we're going to have a parentheses because this line again will never get to 0, okay? So that's the difference with this graph. And we're gonna see that in the next 3 graphs as well. The next graph is called a logarithmic function. There is an M in there. We call it log for short. So this one is y equals log of x. Calculator, y equals, there's a log button, and then you just enter x inside the parentheses. Again, arrow at the end right here. This time it gets flat right here vertically. There is an arrow, okay? And then the domain, how far left does this go? Same process. This is gonna get closer and closer to 0 right here, but it's never gonna reach 0. So we're gonna go from 0, and then how far right to infinity. And again, since it's never gonna reach 0 here, we're gonna use a parentheses. All right, and then the range, how low does it go? Negative infinity. How high? Okay, this will keep increasing slightly. So this is going to be all real numbers. Okay, what I want you guys to notice is a log function is the inverse of an exponential function. So look at the domain and range. So when we have an inverse, those two just swap. Okay, so we had all reals for the domain, 0 to infinity for the range. Here we now have 0 to infinity for the domain and all reals for the range. Okay, and now our last two. This one we're going to call rational odd. Okay, rational is just a fancy way to say fraction mathematically. That equation is going to be y equals 1 over x. Okay, I'll explain the odd in just a second. So now we have kind of a split graph here. Okay, we have this part of our graph, and then we have this part of our graph. Okay, so that's going to affect our domain and range slightly. So if I look at this, this goes to negative infinity, and this side goes to positive infinity. So our domain is going to be all reals, with the exception of, okay, of 0 right here, because remember, these are never going to get to the y or the x-axis. Same thing over here. So zeros are exception. So we have points on all real numbers with the exception of 0. So we write that in the domain all reals, and we say x cannot be equal to 0. Okay. And then the range, same thing. It goes from negative infinity to positive infinity, with the exception of this right here, which is also 0. So all real numbers, y cannot equal 0. And then the last one, a rational even. This equation is going to be y equals 1 over x squared. Okay, so let's talk about the odd and the even. So the even talks about the exponent on the variable x. So it could be 2, 4, 6, 8, okay, but usually it's just 2. So when we come back over here, rational odd still talks to the exponent on the x. Since it's not written, it's actually a 1. So that's an odd number. So 1, 3, 5, 7, so forth, okay? So notice the difference in the graphs. An even, okay, kind of looks this way, and odd, it's kind of catty-corner from each other, okay? So arrow here, arrow there, and then arrow there. Okay, so domain and range. Negative infinity to positive infinity, with the exception of 0. All real numbers, x cannot equal 0. The range, it goes down as far as 0 to positive infinity. So 0 to infinity, it's never going to equal 0, so we use a parentheses. Okay, so the main thing about today is, can we match the equation with a graph, and then can we write the domain and range for those?